Operations with functions. So just like expressions, you can add, subtract, multiply, and divide functions together. Okay, so this is all going to be written in a function notation. So when you add two functions together, we have f plus g of x. So that really means you're going to take f of x plus g of x, like this. Take your two functions and add them up. Subtracting is similar. We're going to have f minus g of x. So again, we're going to do f of x subtract g of x. Remember, when you're subtracting, you need parentheses around this second function. When we're multiplying, here's how it's going to look. Fg, remember when we put two things next to each other, it just means multiply. So f of x times g of x. And then dividing f over g of x is f of x divided by g of x. So there are a couple rules when you start finding domain. So domain of functions, you need to consider what operations in math cannot be performed on the inputs. There are two main rules. Rule number 1 is you cannot divide by 0. So any number that makes a 0 in the denominator cannot be included in the domain. Second rule is radicals with an even index, so like a 2, 4, 6, cannot have negative radicands. So if it's an even index, you cannot have negatives underneath the radical sign. You can have a 0 or higher, but nothing less than 0. So let's do some examples. So here's an addition example. Number 1, given f of x equals 3 square root of x and g of x equals negative 10 square root of x, number 1 says find f plus g of x. So that's the first thing we're going to do. So number 1 is we're going to add these functions together. So now remember, f plus g of x is really saying we're going to take f of x and add g of x to it. So f of x is 3 square root of x plus g of x is negative 10 square root of x. So we're going to combine like terms. Since these both have square roots of x, that means they're both like terms. I can combine these like normal. So the combined function, 3 plus a negative 10 makes negative 7, square root of x. This is the added function, f of x plus g of x. That's part 1. Part 2 is, well, let's find the domain. So part 2, domain. Now the rule that we have to keep track of for this one is the even indexed radicand, because this is actually a 2 as the index. These cannot have negative numbers. They can have 0, but not negative. So my domain would be x greater than or equal to 0. And the last part, step 3, is it asks you to evaluate the sum when x is equal to 4. So step 3, we are actually going to evaluate f plus g of 4. All this means is replace x with 4 in the new function. That's all that means. So to evaluate this, we're going to take this new function we found in step 1, negative 7 square root of x, and we're going to place the x with a 4. So it's going to be negative 7 times the square root of 4. And we're going to simplify as far as we can. Well, square root of 4 is equal to 2, so it's actually negative 7 times 2, which makes negative 14. So the new function evaluated at 4 is equal to negative 14. And that's it for problem 1. Let's try a subtraction. Example 2. Given f of x equals 3x to the third minus 2x squared plus 5, and g of x equals x squared minus 3x to the third plus 4x minus 2, number 1, now it wants us to find f minus g of x. So that means it wants us to find f of x minus g of x. So same thing as before, f of x is 3x to the third minus 2x squared plus 5 minus, now remember, when we do subtraction, we need parentheses on the one that's being subtracted. So I'm going to have to put parentheses, x squared minus 3x to the third plus 4x minus 2. Now we're going to simplify as best as we can. So I'm going to distribute this minus 1. So this becomes 3x to the third minus 2x squared plus 5 minus x squared, distribute to the second term, plus 3x to the third, distribute again, minus 4x, distribute one last time, plus 2. So now combine like terms. So 3x to the third plus 3x to the third is equal to 6x to the third. Then we have negative 2x squared and a negative x squared, which makes negative 3x squared. Then we have a minus 4x by himself, plus 5 plus 2 makes plus 7. So the subtracted function is 6x to the third minus 3x squared minus 4x plus 7. That would all go in this number 1 spot here. Now step 2 is, what is the domain? Well, the only two rules for domain was that I can't divide by 0, but there's no division in this function, and I can't have any negatives underneath even radicals. But there's no radicals in this either. So that means there are no restrictions on the domain. You have a domain of all real numbers. You can either use the symbol or write it out. The last thing it wants us to evaluate f minus g of negative 2. Step 3, f minus g of negative 2. So again, we're going to replace x in our new function with negative 2. So our new function, so 6 times, well, x is now negative 2 to the third, minus 3 times x is now a negative 2 squared, minus 4 times x, which is now negative 2, plus 7. And then we're going to simplify this as far as we can. So negative 2 to the third power is negative 8. That's negative 2 times negative 2 times negative 2. Minus 3 times negative 2 squared makes a positive 4. The next one doesn't have an exponent, so I can go ahead and multiply. Negative 4 times negative 2 is a positive 8. And then drop plus 7. Now keep multiplying. 6 times negative 8 makes negative 48. Negative 3 times 4 makes negative 12, and 8 plus 7, since those are like terms, I can go ahead and combine that together, makes 15. Plus 15. Now we're going to keep combining. Negative 48 minus 12 plus 15 is equal to negative 45. So the value of this new function at x equals negative 2 is negative 45. Okay, multiply. Example 3. Given that f of x equals x to the fourth and g of x equals 3 times the square root of x, number 1, find fg of x. So since f and g are just right next to each other, that really means it wants f of x times g of x. Times. Okay, so we're going to plug these in. So f of x is x to the fourth, so I'm going to have x to the fourth times, and then g of x is 3 square root of x. So trying to multiply an exponent with a radical is not the easiest thing to do. So we're actually going to take this radical and change it into its exponent form. So that was the a m over n equals n root of a to the m. We're going to use that rule to change this to its exponent form. So this is really x to the fourth times 3x to the 1/2 power. Now that I have everything in exponents, I can use my exponent rules to simplify. So because we are multiplying, that means the coefficients get multiplied. So 1 times 3 makes 3, and the exponents are actually added together. So 4 over 1 plus 1 over 2. Make sure you have common denominators. 8 over 2 plus 1 over 2 is equal to 9 over 2. So this is really 3x to the 9/2 power. That is your new function when you multiply f and g together. So 3x to the 9/2. Okay, now let's talk about domain before we start evaluating. So domain of this, there's no fraction, so that's not a problem. But 9/2 is really a square root. So what we really have is the square root of x to the 9th. That's what you really have here. So the domain is x greater than or equal to 0 because even index radicals cannot have numbers less than 0. So my domain is x greater than or equal to 0. Now let's evaluate. Step 3, it says evaluate the product when x is equal to 2. So we're going to substitute a 2. So 3 times 2 to the 9 halves power. Now I'm going to change that 9 halves back to its radical because 2 to the 9 halves power is not something I can easily evaluate. So this is really 3 times the square root of 2 to the 9th. Now we don't need to actually evaluate 2 to the 9th. What I can do is I can actually expand this out as 2 times 2 times 2 times 2. 9 2's all multiplied together. Because remember, square roots want pairs of numbers. So I can pair these up as best as possible. I have 1 2 left without a pair. So what happens is this simplifies into the 3 that was already in the front times 1, 2, 3, 4 2's. Then square root of, and then the 1 2 that was left without a pair. We didn't even need to figure out what 2 to the 9th actually is. So now let's simplify what we have here. 2 times 2 times 2 times 2, that makes 16. And 16 times 3, that will make 48. So we have 48 square root of 2. That is what this new function evaluated at 2 will give us. 48 square root of 2. Last example. F of x equals 4x to the 5/4, g of x equals 2x to the 1/2. Find f over g of x. So step 1 wants us to divide these functions. So we're going to have f of x over g of x. So f of x is 4x to the 5/4 over g of x 2x to the 1/2. So since these are all already in exponent form, I'm going to use my exponent rules to simplify. Since they are divided, that means we're going to divide the coefficients. So 4 divided by 2 makes 2, but we're going to subtract the exponents. So it's going to be x to the 5/4 minus 1/2. Come to the side, do your fraction if you need to. 5 over 4 minus 1 over 2. Give them both common denominators. 5 minus 2 makes 3 over 4. So your final combined, the division of f and g, will give you 2x to the 3/4 power. Alrighty. Now again, let's talk about domain. The domain of this, yes, it is just an exponent, but it's a fractional exponent. So what we actually have is 2 times the 4th root of x to the 3rd. So it's not necessarily all real numbers. Because it's an index that is even, I'm still limited to all the numbers greater than or equal to 0. Okay? Now, step 3 says evaluate the quotient for x equals 16. So that's the third thing we're going to do, is we're going to evaluate at x equals 16. So that means substitute an x of 16. So 16 to the 3/4 power. We're going to change this into our radical form. So it's 2 times the 4th root of 16 to the 3rd. Now this doesn't quite work out as well as last time because I only have 3 16s, but according to my index, I need groups of 4. So a way you can actually write this is we can take this exponent and actually write it this way. 2 parenthesis 4th root of 16 all to the 3rd power. So that exponent inside can either be inside with the radicand or it can be outside the entire radical, and it's going to give you the same answer in the end. Because now I can evaluate the 4th root of 16. I can do that and then just take whatever my answer is and cube it. So let's worry about this 16. So 16 breaks up into 4 times 4. 4 can break into 2 times 2, 2 times 2. And according to my index, I want groups of 4 numbers together. So I have one group of 2's and nothing left without a pair. So this turns into 2 on the outside times, well, the 4th root of 16 gave us a 2. Change my color. 2. And then we still have to cube it in order to take care of that 3 exponent. So 2 to the 3rd power, well, that's going to give us an 8. And then 2 times 8 equals 16. So the function evaluated at x equals 16 is just 16.